Welcome you all to the paper project conducted by GMSA 24. So in this video, I'm going to discuss the multiple choice questions of the physics paper. So if you haven't done the paper, you can find it through the WhatsApp and Telegram links provided in the description below. So before starting this discussion, what I have to tell you is don't try to by heart physics. Physics is an amazing subject with many beautiful concepts. So try to understand these concepts thoroughly and deeply by analyzing in different directions using your imagination. Then you will be able to solve different questions based on these concepts very easily. So without taking much time, let's move on to the discussion. Let's start with the first question. If the dimensions of the temperature is taken as theta, what would the dimensions of specific heat capacity be? So first of all, we should write the equation combining the specific heat capacity and the temperature. That is Q equals mc theta. Then we should take the dimensions on both the sides. So as Q is heat energy, it is a type of energy. So the dimensions of energy is ml squared T minus 2, and the dimensions of M is M, and we should find the dimensions of C, and the dimensions of theta is theta. So M and M cancels. So the dimensions of C is L squared T minus 2 theta to the power minus 1. So the correct answer is the third one. Question number 2. In the diagram are three vectors shown by magnitude and direction. The vectors P and R are perpendicular to each other. If the magnitude of R is half the magnitude of Q, the angle between vectors P and Q is. So if Q is 2x, R will be half of Q, that means it will be x. So if we take this angle as theta, sine theta is opposite divided by hypotenuse, that means x divided by 2x. So that is equal to half. That means theta is equal to 30 degrees. So this is 30 degrees. So they are asking for the angle between the vectors P and Q. So this is the angle between P and Q. So that is 180 degrees minus 30 degrees. That is 150 degrees. So the correct answer is number 5. Question number 3. A particle is in simple harmonic motion. If the amplitude is doubled while keeping the frequency constant, which of the following would also double? A. Maximum velocity of a particle. So the maximum velocity of a particle V is equal to A omega, and omega is equal to 2 pi f. So V will be A into 2 pi f. So when we double the amplitude by keeping the frequency constant, velocity also doubles. So A is correct. B. Maximum acceleration of particle. So maximum acceleration of a particle A is equal to minus omega squared A. So omega is equal to 2 pi f. So when f is constant, omega is also constant. So when we double the amplitude, acceleration also doubles. So B is correct. C. Total energy of a particle. Total energy of a particle E is given by half k a square. So here, when we double the amplitude, the total energy increases by 4 times. Therefore, C is wrong. So only A and B are correct, and the correct answer is the third one. Question number 4. Consider the statements regarding earthquakes. Seismic waves can be mainly categorized into two types as body waves and surface waves. And body waves can again be categorized as P waves and S waves. And surface waves can be categorized as Rayleigh waves and Love waves. So P waves are longitudinal and S waves are transverse. Rayleigh waves are both longitudinal and transverse. Love waves are transverse. The next important thing is P waves travel through all the three media, solid, liquid, and gas. But S waves can travel only through solid. And P waves are faster than S waves. As P waves are faster, they are the first to reach the observatory. Now let's consider these statements. P waves are longitudinal waves. That's correct. S waves are transverse waves. That's also correct. Surface waves are totally longitudinal waves. No, surface waves can be transverse waves or longitudinal waves. Therefore, 3 is wrong. 4. P waves have higher velocity than S waves. That is correct. P waves, which are body waves, reach the observatory first. That is also correct. So, as they're asking for the incorrect statement, the correct answer is the third. Question number 5. What is the graph showing the variation of velocity against the mass of a satellite orbiting the Earth correctly? So, this is the Earth and its mass is capital M, and this is the satellite orbiting the Earth. Its mass is simple m, and this is the velocity v of the satellite, and the distance between the satellite and the center of the Earth is simple r, and F is the centripetal force acting on the satellite. So now let's try to derive an expression for the velocity v of the satellite. So we can apply F equals ma to the satellite. So F equals GMM over r squared, and acceleration equals v squared over r. So GMM over r squared will be equal to mass into acceleration is v squared over r. So 1r and 1r on this side cancel, m and m cancels. So velocity is equal to root gm over r. So that means the velocity of the satellite doesn't depend on the mass of the satellite. That means the velocity of the satellite should be a constant, though the mass of the satellite varies. So therefore, the correct answer is the fifth one. Question number 6. The correct order to adjust a spectrometer for parallel light is. So first, we should adjust the telescope. First, adjust the gap between the eyepiece and the crosswires until the crosswires are clearly seen. Next, point the telescope to a distant object and adjust it until the clear image of the object is focused on the crosswires. Secondly, we should adjust the collimator. Adjust the slit of the collimator to be narrow and vertical and illuminated by a source of light. Next, turn the telescope to be in line with the collimator. Observe the image of the slit through the telescope and adjust the collimator until a sharp image of the slit is focused on the crosswise. The third step is the leveling of the prism table. So the correct order is first we should adjust the telescope, then the collimator, and finally the prism table. So the correct answer is the fourth one. Question number 7. The pressure and volume of a sample of saturated vapor is P and V respectively. If the sample is compressed under isothermal conditions until its volume is halved, the new pressure is. So this is the first instance, and the pressure of the first instance is P and the volume is V. So as the volume is halved in the second instance, the new volume is V over 2. And as this is done under isothermal conditions, the temperature is the same at both the instances. And this is really important. They have mentioned that this is a sample of saturated vapor. That means the pressure at the first instance is equal to the saturated vapor pressure at the given temperature. And as the volume is reduced at the second instance, the vapor at the second instance is also saturated. The excess water vapor is condensed to form liquid water. And as the saturated vapor pressure doesn't change with temperature, the pressure at the second instance should also be P. So the correct answer is the second one. Question number 8. An uncharged capacitor with a capacitance of 500 microfarad is charged at a constant rate of 50 microcoulombs per second. The time it would take to reach a potential of 10 volts is. So if this is the capacitor, it has a capacitance of 500 microfarad. So we can apply Q equals CV to the capacitor. So Q equals to the rate at which the capacitor is charged into the time taken. So we can substitute Q as R into T, and that will be equal to CV. So the rate at which the capacitor is charged is 50 microcoulombs per second, and we should find the time taken, and the capacitance is 500 microfarad, and the voltage is 10 volts. So when you simplify this, you will obtain T as 100 seconds. So the correct answer is the fifth one. Question number 9. A fixed amount of water is in a calorimeter. A heater of 90 watts was immersed in it, and temperature increased and reached a steady temperature of 35 degrees Celsius. The room temperature is 25 degrees Celsius. If a heater of 180 watt is used in place of the 90 watt heater, the steady temperature is. So this is the first instance. So here a 90 watt heater is used and a steady temperature of 35 degrees Celsius is obtained. Why a steady temperature is obtained here? Because here the rate of heat loss becomes equal to the rate of heat generated by the heater. That means the rate of heat loss becomes equal to 90 watt. At the second instance, a 180 watt heater is used, and here a steady temperature of theta degrees Celsius is obtained. The reason for that is because the rate of heat loss becomes equal to 180 watt, and they have given the room temperature as 25 degrees Celsius. So here, in order to find theta, we can apply the Newton's cooling law. So the Newton cooling law states that the rate of heat loss, that means delta Q over delta T, is directly proportional to the temperature difference between the surrounding and the object. That means theta minus theta R. So when applied to the first instance, we can write 90 watt is directly proportional to 35 degrees Celsius minus 25 degrees Celsius. So that means 90 is directly proportional to 10. Similarly, at the second instance, 180 watt is directly proportional to theta minus 25 degrees Celsius. So this is the first one and this is the second one. So when we divide first one by the second one, we will obtain 90 watt over 180 watt is equal to 10 over theta minus 25 Celsius. So when you simplify this, you will obtain theta as 45 degrees Celsius. So the correct answer is the second one. Question number 10. A particle of mass m is projected with an initial velocity of u at an angle theta inclined to the horizon. It falls at the same horizontal level at a distance r from the point of projection. The magnitude of momentum change in this projectile is. So this is the diagram for the projectile, and they have given that the angle of inclination to the horizontal as theta. So this is theta, and if this is theta, this should also be theta, because when a particle is projected with an angle of inclination to the horizontal, and if it falls at the same horizontal level, the velocity when it touches the ground should also have the same angle of inclination as before with the horizontal. So this should also be theta. And they have given the initial velocity as u. So if this is u, the magnitude of the final velocity should also be u, as it falls at the same horizontal level. So then the magnitude of initial momentum will be mu, and the magnitude of final momentum will also be mu. Now they are asking for the magnitude of momentum change in this projectile. So you can't just subtract mu and get the answer as zero, because momentum is not a scale, it is a vector. So in order to solve this, first we will separate the initial momentum into the horizontal and vertical components. Therefore, the horizontal component will be mu cos theta, and the vertical component is mu sin theta. Similarly, when we separate the final momentum into horizontal and vertical components, the horizontal component will be mu cos theta, and the vertical component will be mu sin theta. Now, let's take the change in momentum in the horizontal and vertical directions separately. So, the change in momentum in the horizontal direction will be mu cos theta minus mu cos theta. That means final momentum minus initial momentum, that is zero. Then now we will calculate the change in momentum in the vertical direction. So that is final momentum is mu sin theta minus the initial moment. Now this is really important. We can't just subtract and add vectors in two different directions. They should be in the same direction. So here, as the initial velocity is in the opposite direction to the direction we considered, that will be minus mu sin theta. So the change in momentum in the vertical direction will be 2 mu sin theta. So as there is no change in momentum in the horizontal direction, the magnitude of momentum change in this projectile will be 2 mu sin theta. So the correct answer is the fourth. Question number 11. A parachute is landing at a constant velocity. The reaction force of its weight is. So this is the man, and this is the parachute, and this is the earth. So if this is the weight acting on the man, the reaction force of this weight is the gravitational force created by man on earth. So if it is difficult to understand, it is exactly similar to this situation. Just consider two masses A and B. So if this is the gravitational force acting on A by B, the reaction force of this force will be the gravitational force created on B by A. So these are action and reaction. So consider this as the earth and this as an object on the earth, and this is the weight of the object. So the reaction force of the weight of any object on earth, whether it is stuck in the earth or not, will be the gravitational force created by that object on the earth. So those are always action and reaction. So in this question, the reaction force of the weight of the man will be the gravitational force created by man on Earth. Therefore, the correct answer is the fifth one. Question number 12. A convex lens is placed between a screen and an object. The lens is moved and at two locations, two images of magnification M1 and M2 fall on the screen. M1 is greater than M2. If the distance between the two locations is x, the focal length of the lens is. So this is the first situation and this is the second situation. So here an image is formed on the screen, and while keeping the object and the screen at the same place, when we move the lens, we will obtain another image when the lens is at this location. So the distance between the two locations of the lens is x. So we can take this as the object distance u and this as the image distance v. So here, then this will be u and this will be v, because in this situation, the object distance and the image distance are interchanged. So then we can write an expression for m1. So m1 is the image distance divided by object distance. So as m1 is greater than m2, here the image distance should be greater than the object distance. So that will be v over u, and m2 will be equal to the image distance is u and the object distance is v. Alright, now let's apply the lens formula for the first situation. So 1 over v minus 1 over u equals 1 over f. So when we apply the sign convention, v will be negative, u will be positive, and f will be negative. So this will be minus 1 over v minus 1 over u equals minus 1 over f. So therefore 1 over v plus 1 over u equals 1 over f. So next, v plus u over vu equals 1 over f, and f will be equal to vu over v plus u. Now let's subtract m2 from m1. So that will be v over u minus u over v. So that is equal to v squared minus u squared over uv. So here, as there is a difference of two squares, m1 minus m2 will be equal to v minus u into v plus u over uv. So here you can see f is equal to vu over v plus u. So here we can subject vu over v plus u, that is equal to v minus u over m1 minus m2. So this is equal to the focal length. Then v minus u is equal to x. So the focal length is equal to x over m1 minus m2. So then the correct answer will be the second one. Question number 13. A point charge Q is placed on the center of the central axis of a hypothetical closed cylindrical surface. If the perpendicular electric flux emitted from the curved surface of the cylinder is psi, the flux emitted from one circular surface is. So this is the hypothetical cylinder, and this is the point charge Q, which is placed on the center of the central axis of the cylinder. So pay your attention really carefully to this. So the curved surface of the cylinder is this, and there are two circular surfaces for a cylinder. So these are the two circular surfaces of the cylinder. So they have given that the perpendicular electric flux emitted from the curved surface of the cylinder is psi. So let's take that as psi. And they are asking for the flux emitted from one circular surface. So let's take the flux emitted from one circular surface as psi dash. So the flux emitted from the other circular surface will also be psi dash. So then let's take the total flux emitted from the cylindrical surface as psi t, and that will be equal to 2 psi dash plus psi. So then we can apply the Gauss theorem. According to the Gauss theorem, the total flux emitted will be equal to Q over epsilon naught. Next, we can substitute psi t as Q over epsilon naught. So Q over epsilon naught will be equal to 2 psi dash plus psi. So psi dash will be equal to half into Q over epsilon naught minus psi. So the correct answer is the fourth. Question number 14. If the internal resistance of the cell is negligible, the correct statement is. So this is the circuit they have given. So first of all, let's try to simplify this circuit by replacing these resistors with equivalent resistors. So here you can see these three resistors are in series. Therefore, their equivalent resistance will be 8 ohm because 2 plus 4 plus 2 is equal to 8. Then these two 8 ohm resistors are in parallel. Therefore, their equivalent resistance will be 4 ohm because if two equal resistors are in parallel, their equivalent resistance will be half the value of a single resistor. Then again, these 2 ohm, 4 ohm, and 2 ohm resistor are in series. Therefore, their equivalent resistance will be 8 ohm. And again, these two 8 ohm resistors are in parallel. Therefore, their equivalent resistance will be 4 ohm. Then finally, these three resistors are in series. Therefore, we can apply V equals IR to this circuit. So V will be 9 volts and we should find the current, and R will be 3 plus 4 plus 2, that will be 9. Therefore, I is equal to 1 amp. Therefore, the current produced by the cell will be 1 ampere. Then, as the 1 ampere current flows, and at this junction, the current divides into 2. So let's see how the current divides. So as the resistance is equal in both the paths, the current will equally divide into 0.5 amperes and 0.5 amperes. So therefore, this will be 0.5 amperes and this will be also 0.5 amperes. Then again at this junction, the current is divided into 2. That means here the current is divided into 2. So this is 0.5 amperes. So how does the current divides at this junction? So here also the resistance in both the paths are equal. Therefore, here also the current equally divides into 0.25 amperes and 0.25 amperes. So therefore, the value will be 0.25 amperes and this will also be 0.25 amperes. Okay, now let's consider these statements. The first one, a current of 0.5 amperes flows through the 3 ohm resistor. No, a current of 1 ampere flows through the 3 ohm resistor. Therefore, this is wrong. A current of 0.25 amperes flows through the 3 ohm resistor. No, that is also false. A current of 0.5 amperes flows through the 4 ohm resistor. No. Here, a current of 0.25 amperes flows through the 4 ohm resistor. Therefore, that is wrong. A current of 0.25 amperes flows through the 4 ohm resistor. So the fourth one is correct. Fifth one, a current of 0.75 amperes flows through the 8 ohm resistor. Now, there are two 8 ohm resistors, and a current of 0.5 amperes flows through one, and a current of 0.25 amperes flows through the other. Therefore, fifth one is also wrong. So the correct answer is the fourth. Question number 50. P, Q, and R are three similar vessels of water with ice cubes A, B, and C floating on water respectively. A has an air pocket inside, B has a cork inside, and C has a coin inside. When the ice dissolves, which statement shows the water level change accurately in each vessel? So these are the vessels P, Q, and R, and these are the ice cubes A, B, and C. So there is an air pocket in A and a cork inside B, and there is a coin in C. So some of you may find difficult to solve this question, but you can try to solve it in this way. So first, let's take the volume of the ice in the ice cube as V and the volume of the ice cube submerged in water as V dash. So here also the volume of the ice in this ice cube is V and the volume of the ice cube submerged in water is V dash. So here also it's the same. So now the upthrust acting on the ice cube U is equal to V dash rho W into G. Rho W is the density of water and the weight of the ice cube W is equal to the mass of the ice into G. So here we can neglect the mass of the air. Then this is really important. When the ice cube is dissolved, the mass of the ice is exactly equal to the mass of the dissolved water because the mass doesn't change. Therefore, we can write this as mW into G. mW is the mass of the dissolved ice. That means it's the mass of water. Then mW can be written as density of water into the volume of dissolved water. So let's take that as V1 into G. Now, as the ice cube is floating, the weight is exactly equal to the upthrust. So we can write rho W into V1 into G is equal to V dash into rho W into G. So rho W, G and rho W, G cancels. Therefore, V1 is equal to V dash. So that means the volume of the water after the ice cube is dissolved is exactly equal to the volume of the ice cube submerged in water. That means the dissolved water exactly fits into the volume of V dash. Therefore, there will be no change in the water level of vessel P. So now let's consider the second instance. So this is exactly similar to the first instance. So here also the upthrust acting on the ice cube U can be written as V dash into rho W into G, and the weight of the ice cube is the mass of ice into G because we can neglect the mass of the cork. And so here also, when the ice cube is dissolved, the mass of the ice is exactly equal to the mass of the water after it is dissolved. Therefore, we can write this as mW into G. mW is the mass of the dissolved ice. So mW can be written as rho W into the volume of dissolved ice. So let's take that as V2 into G. So here, as the ice cube is floating, the upthrust is exactly equal to the weight. Therefore, V dash into rho W into G is equal to rho W into V2 into G. So here rho W and G cancels and V dash is equal to V2. So therefore, here also, when the ice cube is dissolved, the dissolved water exactly fits into the volume V dash. Therefore, there will be no change in the water level of vessel Q. Now let's consider the third instance. Here, a coin is inside the ice cube. So here also we can write the upthrust acting on the ice cube is equal to V dash into rho W into G. And the weight of the ice cube can be written as W equals the mass of the ice into G plus the mass of the coin into G. And as the mass of the ice is exactly equal to the mass of the water after it is dissolved, we can write Mi equals Mw, and the mass of the dissolved water is the density of water into the volume of the dissolved water. So let's take that as V3. So we can write W equals rho W V3 into G plus the mass of the coin into G. So as the ice cube is floating, the weight of the ice cube is exactly equal to the upthrust. Therefore, we can write rho W into V3 into G plus MC into G is equal to V dash into rho W into G. So here G, and G cancels. So here you can see rho W and rho W are on both the sides, but as there is a term in C, that means the mass of the coin, V3 should be less than V1. Therefore, V3 is less than V1. That means when the ice cube is dissolved, the volume of the dissolved water is less than the volume V dash. That means when the ice cube is dissolved, the water level in the vessel R will decrease. Therefore, the water level doesn't change in the vessels P and Q, but the water level decreases in the vessel R. Therefore, the correct answer is the second. Question number 16. Let the ratio between the main specific heat capacities be gamma for an ideal gas. At a certain temperature, its sound velocity is v, and the root mean square speed of air particles is u. The ratio between v and u is. So we can easily solve this by first writing the equation for v and u. So the equation for sound velocity v is root gamma or T over M. So that is the first equation. And the equation for root mean square speed of air particles U is root 3RT over M. That is the second equation. So when we divide the first one by the second one, we can easily get the answer. So V over U equals root gamma RT over M divided by 3RT over M. So RT and M cancels off. So V over U is equal to root gamma over 3. So the correct answer is the first one. Question number 17. Two metal rods of length L1 and L2 are completely lead. When the same temperature difference is maintained across the two ends of the rods, the rate of heat flowing through both the rods are equal. If the thermal conductivities of the rods are K1 and K2, and the cross-sectional areas are A1 and A2 respectively, the correct relationship is. So these are the two metal rods, and their cross-sectional areas and lengths are respectively A1 and A2, and L1 and L2. So their thermal conductivities are K1 and K2. And as they have mentioned that the same temperature difference is maintained across the two ends of the rods. Here the temperature is θ1 and θ2. So here also it should be θ1 and θ2. So we can write an expression for the rate of heat flow through the first rod. So R equals K1 A1 into θ2 minus θ1 over L1. Similarly, for the second rod, R equals K2 A2 θ2 minus θ1 over L2. So as they have mentioned that the rate of heat flowing through both the rods are equal. So if this is the first one, this is the second one, the first expression is equal to the second expression. Therefore, K1 A1 into theta 2 minus theta 1 over L1 equals K2 A2 theta 2 minus theta 1 over L2. So theta 2 minus theta 1 cancels, and we can obtain A1 A1 into L2 equals K2 A2 into L1. So accordingly, the correct answer is the second one. Question number 18. The angle subtended on the objective lens of a telescope by a celestial object located far away is 0.03 rad. Focal length of the objective and eyepiece is 20 centimeters and 2 centimeters respectively. The height of the intermediate image formed by the objective lens is. So this is the ray diagram for the astronomical telescope, and they have given that the celestial object is located far away. Therefore, the rays should come parallelly towards the telescope. And as the rays are coming parallelly towards the objective lens, the image of the objective lens should form on the focal point of the objective lens. Therefore, the image distance of the objective lens is equal to the focal length of the objective lens. And they have given the focal length of the objective lens as 20 centimeters. And beta is the angle subtended on the objective lens of the telescope by the celestial object. And they have given that as 0.03 rad. And if this is beta, this should also be beta. So here they are asking us to find the value of h. So this question is really easy, but in order to solve this, you should know this assumption. Small values of theta in radians is nearly equal to tan theta. Therefore, beta is nearly equal to tan beta. So tan beta is equal to the opposite. That means h divided by the adjacent is the focal length of the objective. So beta equals 0.03 rad, and we should find h, and the value of the objective focal length of the objective lens is 20 centimeters. Therefore, h equals 0.6 centimeters. So the first one is the correct answer. Question number 19. A stable has 100 horses and then decides to increase the amount of horses up to 1000. By how much would the sound intensity level increase? So first of all, we should find by how many times the sound intensity is increased. So the sound intensity is directly proportional to the number of horses. Therefore, at the first instance, the sound intensity is directly proportional to 100, and at the second instance, the sound intensity is directly proportional to 1000. So this is the first one, and this is the second one. So when we divide the second one by the first one, we'll obtain I2 over I1 as 1000 over 100. So that is equal to 10. So next, we should find the increase in the sound intensity level. So the equation to find the increase in the sound intensity level is delta beta equals 10 log base 10 I2 over I1. So I2 over I1 is the ratio between the sound intensities at any given two instances. So this will be 10 log base 10, 10. The value of log 10 is 1. Therefore, this will be 10 decibel. So the sound intensity level will increase by 10 decibels. So the correct answer is the third one. Question number 20. A lead wire of radius r and length l acts as a fuse. It melts off once a current of I passes for time t through it. If the length of it was increased to 3L and allowed the same current to pass through, the time it would take to melt. So this is the lead wire of length L, and this is the lead wire of length 3L. So At both the instances, the same current of I passes through it. So the time taken to melt the lead wire of length L is T. So if we consider the amount of heat energy required to melt the lead wire of length L as E, the amount of heat energy required to melt the lead wire of length 3L will be 3E, because the mass of the lead wire is increased by 3 times as the length of the lead wire is increased by 3 times. Then let's consider the rate of heat energy produced at the first instance as P, or the power as P. And now let's try to find the rate of heat produced at the second instance. So R equals rho L over A. So as rho and A, that means resistivity and area of cross section are constant, R is directly proportional to L, and P is equal to I squared into R. So when we increase the length by 3 times, the resistance will also be increased by 3 times. And as the resistance is increased by 3 times, the power also increases by 3 times. Therefore, the rate of heat energy produced at the second instance is 3P. And let's consider the time taken to melt this lead wire as T dash. So here E will be equal to P into T, and here 3E will be equal to 3P into T dash. So this is the first one and this is the second one. So when we divide the second one by the first one, we will obtain 3E over E is equal to 3P into T dash over P into T. So when we simplify this, T dash will be equal to T. So at the second instance also, the time required to melt the lead wire will be T. So the correct answer is the third one. Question number 21. A cylindrical vessel of linear expansivity alpha is filled with a liquid of volume expansivity gamma up to a height h1. The temperature of the whole system is now increased by theta. The height of the liquid now changes to h2. What is h1 over h2? So this is the first instance, and this is the instance when the temperature is increased by theta. So h1 is the height of the liquid at the first instance, and h2 is the height of the liquid at the second instance. So let's take the area of cross section at the first instance as A1 and at the second instance as A2. And also let's take the volume of the liquid at the first instance as V1 and at the second instance as V2. So V1 is equal to A1 into H1 and V2 is equal to A2 into H2. Now let's write expressions combining these terms. So A2 is equal to A1 into 1 plus 2 alpha theta. We write 2 alpha because this is an area. So then V2 is equal to V1 into 1 plus gamma theta. So V2 is equal to A2 into H2 and V1 is equal to A1 into H1. So they are asking for the ratio of H1 over H2. So H1 over H2 is equal to A2 over A1 into 1 plus gamma theta. So we can obtain the ratio of A2 over A1 from here, that is equal to 1 plus 2 alpha theta. So here H1 over H2 will be equal to 1 plus 2 alpha theta over 1 plus gamma theta. So the correct answer is the third one. Question number 22. which of the following logic gates would output Q equals 1? So let's consider one by one. The first one is an AND gate. So in an AND gate, the output will be 1 only when all the inputs are 1. So here one input is 0, therefore the output will be 0. The second one is an OR gate. In an OR gate, even if one input is 1, the output will be 1. But here, both the inputs are 0, therefore the output is also 0. Third one, so this is a NOR gate. So a NOR gate is composed of an OR gate followed by a NOT gate. So at the OR gate, as one input is 1, the output will be 1. And the NOT gate will give the output as the opposite of the input value. So here the output will be 0. The fourth one, it's an AND gate. So an AND gate consists of an AND gate followed by a NOT gate. So here at the AND gate, as one input is 0, the output will be 0, and the NOT gate will make the output as 1. And the fifth one is an XOR gate. So in an XOR gate, the output will be 1 only when the inputs are different. So here, as both the inputs are the same, the output will also be 0. So the output Q will be 1 in the NAND gate. So the correct answer is the fourth. Question number 23. M and N are parallel surfaces separating the three media A, B, and C. A light ray undergoes total internal reflection in the B medium and refracts as it travels from medium B to C. The ascending order of light speed in the three media is shown by. So here, when the light is directed from B to A, total internal reflection occurs, and when the light is directed from B to C, refraction occurs. So always total internal reflection occurs when the light is directed from a denser medium to a rarer medium. So the medium B is denser and A is rarer. And here, when the light is directed from B to C, the light ray bends away from the normal. That means the medium B is denser and the medium C is rarer. Now, how can we find which one out of A and C is the more rarer medium? So we can find it in this way. So let's take this angle as theta. So this angle will also be as theta. And as these two surfaces are parallel, this angle will be theta. Now, when the angle of incident is theta, total internal reflection happens here, but here, though the angle of incident is the same as theta, total internal reflection doesn't happen. That means the difference in the refractive indices between the mediums A and B is greater than the difference between the refractive indices of the mediums B and C. Therefore, the more rarer medium out of A and C is A. So when we arrange the three media from the densest medium to the rarest medium, the densest medium will be the medium B, and then it will be C, and the rarest medium will be A. So now how can we find the order of light speed in the three media? So the light speed will be the lowest in the densest medium. So therefore, the light speed is the lowest in the medium B, and then it will be a little bit faster in the medium C, and it will be the fastest in the medium A. So therefore, the correct answer is the third. Question number 24. A satellite of mass m rotates around the Earth in a circular orbit of radius r around the center of the Earth with a uniform angular velocity omega. The work done on the satellite by the gravitational force when it completes one rotation is. So this is the Earth, and this is the satellite, and this is the orbit of the satellite. So this is a very easy question. You can analyze this question in two ways. So what is work done? So work done is the force into displacement. So the displacement should be in the direction of the force. So here you can see the satellite always moves perpendicular to the direction of the gravitational force. Therefore, no work is done on the satellite by the gravitational force. Therefore, the work done on the satellite by the gravitational force when it completes one rotation is zero. Or you can think about it in this way. So this orbit or this line is an equipotential orbit or line because the gravitational potential is the same at every point on this line. Therefore, when an object moves in an equipotential line, no work is done on it. Therefore, the correct answer is the first one. Question number 25. The rate of fluid flow of a streamlined fluid which flows through a capillary tube of radius r and pressure difference P is Q. If the radius of the tube is reduced to r over 2 and the pressure difference is doubled, what would the new rate of fluid flow be? So you can easily solve this using the Poisson's equation. So that is Q equals pi r to the power 4 over 8 meter into P over delta L. So they are asking if the radius of the tube is reduced to r over 2 and the pressure difference is doubled, what would the new rate of fluid flow be? So let's take the new rate of fluid flow as Q dash, and that is equal to pi r over 2 to the power 4 over 8 meter into 2p over delta L. So that is equal to 5 r to the power 4 over 8 meter into p over delta L into 1 over 8. So that is equal to q dash, and q dash is equal to q over 8. So therefore, the new rate of fluid flow is q over 8. So the correct answer is the fourth. Question number 26. In a radioactive sample, nuclei of element X decay to form stable nuclei of Y. The variation of Y with time t is best represented by. So X decays to form the stable element Y. So first, let's consider the variation of X with time. So initially, only X is present, and with time, X gradually decreases like this. And when we consider the variation of Y with time, initially, Y is not present. So at time t equals 0, Y should also be 0. And with time, as X decays, Y is produced and it becomes a constant. Therefore, accordingly, the correct answer should be the third. Question number 27. Two soap bubbles of radii R1 and R2 join together under isothermal conditions to form a single soap bubble of radius R. If the atmospheric pressure is P naught, the coefficient of surface tension of soap would be. So this is a really good question. So this is the soap bubble with the radius R1, and this is the soap bubble with the radius R2, and this is the soap bubble with the radius R. And let's take the pressures inside these three bubbles as P1, P2, and P, and the number of moles within each soap bubble as N1, N2, and N, and the volume of each soap bubble as V1, V2, and V3. So they have given that the atmospheric pressure is P naught. So you all know this expression. Delta P is equal to 4T over R. Delta P is the pressure difference between the inside and outside of the soap bubble. So here that is equal to 4T over R, not 2T over R. That's because the soap bubble has two surfaces. Then now let's apply this expression to the first sub-bubble. So here it will be P1 minus P naught is equal to 4T over R1. Similarly, for the second sub-bubble, P2 minus P naught is equal to 4T over R2. And for the third sub-bubble, it is P minus P naught is equal to 4T over R. Now let's subject P1 here, that is equal to 4T over R1 plus P naught, and here P2 is equal to 4T over R2 plus P naught, and here P is equal to 4T over R plus P naught. Then let's apply PV equals nRT. So N is equal to PV over RT. So here the number of moles present within these two soap bubbles is equal to the number of moles present in the final soap bubble. Therefore, N1 plus N2 is equal to N. And we can replace N with PV over RT. So therefore, P1 V1 over RT plus P2 V2 over RT is equal to PV over RT. And as this is done under isothermal conditions, the temperature is the same at both the three situations. Therefore, RT, RT, and RT cancel. Then, as the volume is equal to 4 over 3 pi r to the power of 3, we can replace volume with this term. So therefore, P1 into 4 over 3 pi r to the power of 3 plus P pi r1 to the power of 3 plus P2 into 4 over 3 pi r2 to the power of 3 is equal to P into 4 over 3 pi r to the power of 3. So the 4 over 3 and 5 term cancels. Therefore, P1 r1 to the power of 3 plus P2 r2 to the power of 3 is equal to P r to the power of 3. Then we can replace the P1, P2, and P with these expressions. Therefore, for T over R1 plus P naught into R1 to the power of 3 plus 4T over R2 plus P naught into R2 to the power of 3 will be equal to 4T over R plus P naught into R to the power of 3. Then when we simplify this, we will obtain 4T into R1 to the power of 2 plus R2 to the power of 2 minus R to the power of 2 is equal to P naught into R to the power of 3 minus R1 to the power of 3 minus R2 to the power of 3. Now we have to find the surface tension coefficients of the surface tension of cell. Therefore, we should subject T. So therefore, P naught into R to the power of 3 minus R1 to the power of 3 minus R2 to the power of 3 over 4 R1 to the power of 2 plus R2 to the power of 2 minus R to the power of 2. So accordingly, this is the surface tension of soap. So accordingly, the correct answer will be the fourth. Question number 28. A small solid sphere made with a material of density sigma attains a terminal velocity v1 when it travels through a viscous fluid of density rho. Another solid sphere having the same radius but made with a material of density 2 sigma attains a terminal velocity v2 in the same viscous fluid. The ratio of V1 over V2 is given by. So there is an expression for the terminal velocity attained by a small spherical body moving through a viscous liquid. So if you know that expression, you can directly get the answer for this question. But if you doesn't know that expression, you should derive it in this manner. So this is the spherical object, and W is the weight of the object, and U is the upthrust acting on it, and F is the viscous force acting on it, and sigma is the density of the material of the body, and rho is the density of the fluid, and V is the terminal velocity of the sphere. So here F is equal to 6 pi neta A into V, and upthrust is equal to V rho G. So V is the volume, so we can replace that with over 3 pi A to the power 3 and rho into G. And W is equal to mg, and mass is density into volume, and this is G, and volume is 4 over 3 pi A to the power of 3 and sigma into G. So here the sum of the viscous force plus the thrust is equal to the weight. So therefore the viscous force is equal to W minus U. Therefore 6 pi neta AV is equal to 4 over 3 pi A to the power 3 sigma G minus 4 over 3 pi A to the power 3 rho G. Then here we can cancel the 5 terms and we can divide by 2. This will be 3, this will be 2, and this will be 2. And we can cancel A, and therefore V is equal to 2A to the power of 2 into G into sigma minus rho over 9 neta. So this is the expression I told earlier. So if you know this expression, you can directly start from this step. But if you don't know this expression, you should derive that. So now we can write as they have given the terminal velocity as v1. We can write v1 is equal to 2 a to the power 2 g into sigma minus rho over 9 meter. And for the second situation, v2 is 2 a to the power 2 g into 2 sigma minus rho over 9 meter. So this is the first one and this is the second one. So they are asking for the ratio of V1 over V2. So we can divide the first one by the second one. So therefore V1 over V2 is equal to sigma minus rho over 2 sigma minus rho. So accordingly, the correct answer will be the third. Question number 29. In the given circuit, if there is no current flow through the galvanometer, the value of the resistor R would be. So this is the circuit they have provided, and there is no current through the galvanometer. That means this current of 2 amperes divides into these two parts and travel only through those two parts and combines again to form the 2 ampere current. So first of all, let's ground this position. So the potential at this point will be 0 volts, and the potential at this point will also be 0 volts. And as the internal resistance is 0, the potential here will be 2 volts. And as a current doesn't flow through the galvanometer, the potential here should also be equal to 2 volts. Now we can find the current flowing through the 20 ohm resistor. So we can apply V equals IR with the 20 ohm resistor. So the voltage difference across the 20 ohm resistor is 2 volts, and we should find the current, and the resistance is 20 ohm. So the current will be 0.1 amperes. That means here a current of 0.1 amperes flows through this path, and a current of 2 minus 0.1 amperes flows through this path. That means it's 1.9 amperes. Now we can find the voltage difference across this 40 ohm resistor. So we can apply V equals IR to that resistor. So I is 0.1 amperes and R is 40 ohm. So that will be equal to 4 volts. So this is 4 volts. And as this is 4 volts, the voltage difference across the R resistor will also be 4 volts. Now we can easily find the value of R. So we can apply V equals IR to the R resistor. So V is 4 volts and I is 1.9 amperes, and we can find the resistance. So R is equal to 2.1 ohm. So the correct answer is the second. Question number 30. The radiation of energy E falls perpendicularly on a perfectly reflecting surface. If the velocity of light is c, the change of linear momentum transferred to the surface would be. So we know that E is equal to mc squared. Then we can write this as mc into c. So mc is the momentum. So we can write this as E equals momentum into c. So momentum is equal to E over c. Here, the radiation of energy E falls perpendicularly on a perfectly reflecting surface, and it bounces back in the path it came before. So the change of linear momentum would be delta P, that is final momentum minus initial momentum. So the final momentum is E over c minus the initial momentum. So as the initial momentum is in the opposite direction to that of the final momentum, that will be minus E over c. Therefore, the change in momentum is 2E over c. Therefore, the change of linear momentum transfer to the surface would be 2E over c. The fourth one is the correct answer. Question number 31. Consider the following statements regarding electromagnetic waves. A. They have the same speed in different media. No, that is false because they have different speeds in different media. For example, in the denser medium, the speed is less, and in the rarer medium, the speed is high. Therefore, A is wrong. B. They have different wavelengths in different media. That is correct because the wavelengths of electromagnetic waves changes when they enter from one medium to another. C. The same beam of light has different colors in different transparent medium. No, that is false because the same beam of light have the same color in different medium because the color depends on the frequency of the light and it doesn't change in different medium. Only the speed and the wavelength of electromagnetic waves changes when they enter from one medium to another. Therefore, C is also wrong. So only B is correct. So the correct answer is the second one. Question number 32. In a lightning flash, a charge of 30 coulomb travels across a potential difference of 10 to the power 9 volts. What is the maximum mass of ice at 0 degrees Celsius that can be melted by the heat produced during this event? Specific latent heat of fusion of ice is 3 into 10 to the power 5 joules per kilogram. So here E is equal to Q into V. So Q is the charge and V is the voltage. So when you multiply Q by V, you will get the amount of energy released. So then E is equal to M into L. M is the mass of the ice and L is the specific latent heat of fusion of ice. So when you multiply M by L, it will give the amount of heat energy required to melt the ice. So we can replace E by M into L, that is equal to Q into V. So M into the latent heat of fusion of ice is 3 into 10 to the power 5 into Q is 30 coulomb, and the voltage is 10 to the power 9 volts. So this will be 4 and this will be 10. So M is equal to 1 into 10 to the power 5 kilogram. So the maximum mass of ice that can be melted is 1 into 10 to the power 5 kilogram. So the correct answer is the fourth one. Question number 33. A particle of mass m and charge q enters a magnetic field perpendicular to the field line with a velocity v and travels in a circular path of radius r. If a particle of mass 2m and charge q enters the field with a velocity v over 2 in the same manner, the radius of its circular path would be. So these are the two instances, and at the first instance, the velocity of the particle is v, and at the second instance, the velocity of the particle is v over 2, and the masses of the particles are m and 2m respectively, and the radius of the circular path in the first situation is r, and we should find the radius r dash of the circular path of the second situation. And the charge of the particle q is the same in both the instances. So F is the centripetal force acting on the particle in the first situation. So we can write an expression for F, and that is equal to BQV. And the centripetal acceleration is equal to V squared over R. So we can apply F equals ma to this particle. So F is BQV, and the mass is m, and the acceleration is v squared over r. So we cancels, therefore r equals mv over pq. So similarly, the centripetal force acting on the mass 2m, F dash is equal to bq into v over 2, as the velocity is v over 2. And the centripetal acceleration is v over 2 squared into 1 over r dash. Therefore, it is v squared over 4r dash. So we can apply F equals ma to the mass 2m. So F will be bqv over 2, and the mass is 2m, and the centripetal acceleration is v squared over 4r dash. So this 4 cancels, and 1 v cancels. Therefore, r dash is equal to mv over bq. So you can see both r and r dash are equal. Therefore, r dash is equal to r. Therefore, the radius of the circular path at the second situation is r. Therefore, the correct answer is the first one. Question number 34. Initially, q equals 1 and q bar equals 0. What will be the values of q and q bar respectively after the following sequence? So this is an SR flip-flop. So this is what's inside an SR flip-flop. So there are two NOR gates where each of its output is connected to one another's input. So this is the truth table of the SR flip-flop. And in an SR flip-flop, there are two inputs called S and R. That means the set and the reset. And there are two outputs called Q and Q bar. So usually Q and Q bar should have the opposite values because they are named as Q and Q bar. That means the opposite of Q. So now let's analyze the truth table of the SR flip-flop to find out the outputs for different combinations of input. So when S equals 0 and R equals 0, that means when none of the set and reset buttons are pressed, Q and Q bar will remain unchanged. That means the values of Q and Q bar will be same as the previous values. Then when S equals 1 and R equals 0, that means when the set button is pressed, Q will become 1 and Q bar will become 0. So then when the set button is released, it will go back to the previous state where S equals 0 and R equals 0. So Q will remain at 1 and Q bar will remain at 0. And when the reset button is pressed, Q will be reset to 0 and Q bar will become 1. And when the reset button is released, again it will go back to this state where S equals 0 and R equals 0, and Q will remain at 0 and Q bar will remain at 1. So what happens when both the S and R values become 1? So that state is invalid because we don't press both the set and reset buttons at once. Now let's try to do this question. So in this question they have mentioned initially Q equals 1 and Q bar equals 0. What will be the values of Q and Q bar respectively after the following sequence? So here initially S equals 0 and R equals 1. That means the reset button is pressed. So when the reset button is pressed, Q will be reset to 0 and Q bar will become 1. And in the next step, the reset button is released. So therefore, S becomes 0 and R becomes 0. So therefore, Q will remain at 0 and Q bar will remain at 1. So, and again, the reset button is pressed. So therefore, as Q is now 0, it will remain at 0 and Q bar will remain at 1. So the new values of Q and Q bar will be 0 and 1 respectively. So the correct answer is the second one. Question number 35. Consider two objects dropped from the same height with a 1 second interval. How long after the first object is dropped will the distance between the objects become 10 meters? So this is the first object and this is the second object, and they both are dropped from the same height, and at a certain instance the distance between the two objects will become 10 meters. So let's take the displacement done by the first object as S1 and the displacement done by the second object as S2. So the gravitational acceleration will be G, which is equal to 10 meters per square second. And let's take the time taken by the first object to reach this point as t seconds. So therefore, the time taken by the second object to reach this point will be t minus 1 seconds, because the second object is released 1 second after the first object is released. So now we can apply S equals ut plus half at squared to both the objects. So first let's apply to the first object. So therefore S1 is equal to, as the initial velocity is 0, the term ut will become 0. Therefore r into the gravitational acceleration is 10 into t squared. So this is equal to 5t squared. Similarly, we can apply the same equation for the second object. So therefore, S2 is equal to, as the initial velocity is 0, the term ut is 0. Therefore, this will be half into 10 into t minus 1 square. So this is equal to 5 into t minus 1 square. So then S1 minus S2 will be equal to 5t squared minus 5 into t minus 1 square. So this is equal to 5t squared minus 5t squared plus 10t minus 5. So S1 minus S2 will be equal to 10 meters. So 5t squared and 5t squared cancels. Therefore, t will be equal to 1.5 5 seconds. So therefore, how long after the first object is dropped will the distance between the objects become 10 meters? So that will be after 1.5 seconds. So therefore, the correct answer is the first one. Question number 36. Consider the following statements made regarding an electric field. If the electric field intensity at a point is zero, then the electric potential is also zero at that point. No, that is wrong. Consider this instance. So here a plus Q charge is placed at this point and another plus Q charge is placed at this point. And the electric field lines in this situation can be denoted like this. So what is electric field intensity? Electric field intensity is the force acting on a unit positive charge placed in an electric field. So what is the electric field intensity at this point? The electric field intensity at this point is zero because when a unit positive charge is placed at this point, two equal forces will act in opposite directions due to the plus Q charges placed on either sides. Therefore, the two forces cancel off, giving a net force of zero. Therefore, the electric field intensity at this point is equal to zero. So what about the electric potential at this point? What is electric potential? Electric potential is the work done in bringing a unit positive charge from infinity up to a certain point in an electric field. So here, definitely, we have to spend energy when bringing a unit positive charge from the infinity up to this point. Therefore, there is an electric potential at this point. So the electric potential V at that point can be written as 1 over 4 pi epsilon Q squared over R. So therefore, though the electric field intensity at this point is zero, there is an electric potential at that point. The electric potential is not zero. Therefore, X is wrong. Why? If the electric potential is zero at a point, then the electric field intensity is also zero at that point. Let's consider this instance. So here a plus Q charge is placed at this point and a minus Q charge is placed at this point. And the electric field lines can be denoted like this. So when a unit positive charge is placed at this point, the force acts in this direction due to the minus Q charge, and another force acts in the same direction due to the plus Q charge. Therefore, the electric field intensity E at that point can be written as 1 over 4 pi epsilon 2Q over R squared. So what about the electric potential at this point? The electric potential at this point is equal to zero because a plus Q charge and a minus Q charge are placed at an equal distance either side of this point. So that means the electric potential at a certain point is zero and electric field intensity can exist at that point. So therefore, Y is also wrong. He said, if the electric potential is zero throughout a region, then the electric field intensity is also zero throughout that region. That is correct. The electric potential can be zero throughout a region only when an electric field doesn't exist in that region. So therefore, definitely the electric field intensity in that region is zero. Therefore, Z is correct. So the above statements only Z is true. Therefore, the correct answer is the third one. Question number 37. The circuit shown in the diagram is placed in a uniform magnetic field which is directed into the paper. Magnitude of that magnetic field is increased at a rate of 150 Tesla per second. Reading of the ammeter would be. So this is the circuit and the magnetic field is directed into the paper, and in this case that means the magnetic field is directed into the screen. So they have mentioned that the magnitude of the magnetic field is increased at a rate of 150 Tesla per second. So what happens when the magnitude of the magnetic field is increased? Then an electromotive force will be induced in the circuit. So here we can apply the Faraday's law. So according to the Faraday's law, E will be equal to delta psi over delta T. So E is the induced electromotive force and delta psi over delta T is the rate of change of magnetic flux. And the Faraday's law states that the magnitude of the induced electromotive force in a circuit at any instance is directly proportional to the rate of change of magnetic flux at that instance. And we know delta psi is equal to delta VA. Psi is the magnetic flux and V is the magnetic flux density. So the change in magnetic flux is equal to the change in magnetic flux density into area. So here we can substitute delta psi by delta BA and over delta T. So delta B over delta T is the rate of change of magnetic flux density. So in this case, that is 150 Tesla per second. So here we can substitute the values. So this is equal to 150 Tesla per second and A is equal to 0.1 meters into 0.1 meters. So that is equal to 1.5 volts. So that means here the induced electromotive force is 1.5 volts. So now what we should find is the direction of the induced electromotive force. So for that we can use the Lenz's law. So the Lenz's law states that the direction of the induced electromotive force is such that its current flows in a direction opposing the change of flux causing it. So here you can use the right hand grip rule, and according to the Lenz's law, as the magnetic flux density is increasing in the direction directed into the screen, the current will be induced in the anti-clockwise direction. And the induced electromotive force of 1.5 volts will be in this direction. So now we can apply V equals IR to the circuit. So V will be 5 plus 1.5 volts and we should find the current and the resistance is 10 ohm. So I is equal to 0.65 amperes. So therefore the reading of the ammeter would be 0.65 amperes. So the correct answer is the fourth. Question number 38. A uniform cubical wooden block of side length A is moving along a smooth horizontal plane with a velocity v as shown in the figure. The mass of the block is m and the moment of inertia around a horizontal length through A is I. The angular velocity of the block about A due to collision of edge A with a small ridge at O would be. So this is the block and this is the small ridge A which is colored in blue color. And the side length of the cube is A and its velocity is V and the mass of the cube is M. So this is the diagram for the instance where the wooden block just collides with the small ridge. So during the collision, a force will be acted on the wooden block through A by the small ridge. But as the torque is equal to the force into the distance, when we consider the torque about point A as the distance to this force from point A is 0, there will be no torque acted on the wooden block about point A during the collision. So therefore, as no torque is applied during the collision, the angular momentum of the wooden block about point A should be conserved. Therefore, the angular momentum of the wooden block about point A before the collision should be equal to the angular momentum of the wooden block about point A after the collision. So now let's consider the linear momentum P of the wooden block before the collision. That is equal to m into v. Then, as the angular momentum is equal to the linear momentum into the distance, the angular momentum about point A before the collision is equal to m into v into the perpendicular distance to the center of gravity from point A is A over 2. And they have given that the moment of inertia around A as I, and let's take the angular velocity just after the collision as omega. So therefore, the angular momentum about point A just after the collision is equal to I into omega. So as the angular momentum is conserved during the collision, the initial angular momentum should be equal to the final angular momentum. Therefore, these two expressions are equal. Therefore, mva over 2 is equal to I omega. So from this expression, we can subject omega. So omega is equal to mva over 2I. So therefore, the angular velocity of the block about A due to collision of edge A with a small ridge at O would be mva over 2I. So the correct answer is the fourth. Question number 39. A parallel beam of light passes through a convex lens as shown in the figure. The correct relationship between refractive indices of each medium is. So this is the convex lens, and when light enters from the first medium to the second medium, no deflection of light occurs. That means the refractive indices of the first medium and the second medium are equal. Therefore, N1 is equal to N2. Then what happens when the light enters from the second medium to the third medium? So we can draw a normal to the point of incident like this. Then we can see the light ray has bent towards the north. That means the third medium is more denser than the second medium. Therefore, N3 is greater than N2. That means N1 and N2 are equal and N3 is greater than N1 and N2. So the correct answer is the fourth. Question number 40. A positive charge is given to a simple pendulum and a negatively charged plate is placed below it. When it is oscillated, in addition to the length of the pendulum and the gravitational acceleration, the periodic time of the pendulum bob depends on. So this is the pendulum bob, and the length of the pendulum is L, and the mass of the pendulum bob is M, and the gravitational acceleration is G. So therefore, the weight of the pendulum bob is mg. And let's take the charge given to the pendulum bob as plus q. And this is the negatively charged plate. So as a negative charge is given to the plate, an electric field acts in the downward direction. So as a plus q charge is given to the pendulum bob, due to this electric field, an electrostatic force acts on the pendulum bob in the downward direction. So let's take that electrostatic force as F. So let's take the electric field intensity here as E. So F is equal to E into Q. E is the electric field intensity and Q is the charge. So when we multiply electric field intensity by the charge, we'll obtain the electrostatic force. Then we can apply F equals MA to the pendulum bob. So F will be the electrostatic force plus the weight. So that is equal to MA. So therefore A is equal to EQ over M plus G. So here A is called the effective gravitational acceleration. So here it is greater than G as an electrostatic force acts in the downward direction due to this negatively charged plate. So you know the periodic time T of a pendulum bob is equal to 2 pi root L over G. So let's take this as G dash, and that is the effective gravitational acceleration on the pendulum bob. So therefore T is equal to 2 5 root L over G plus EQ over M. So using this equation, we can find the factors the periodic time of the pendulum bob depends on. So the periodic time of the pendulum bob depends on the length of the pendulum bob, the gravitational acceleration, then the mass of the pendulum bob, the charge of the pendulum bob, and the electric field intensity E. So the electric field intensity E depends on the charge of the plate. So therefore, in addition to the length of the pendulum and the gravitational acceleration, the periodic time of the pendulum bob depends on the mass of the pendulum bob, charge of the pendulum bob, and charge of the plate. Therefore, the correct answer is the fifth. Question number 41. Mercury of mass m and density rho is poured into a bent vertical tube with cross-sectional area A. The right arm is inclined at an angle alpha to the horizon. The left arm is inclined to the vertical at an angle beta. If viscous effects and surface tension are neglected, what would be the period of the simple harmonic motion of the mercury column? So this is the bent vertical tube, and when mercury is poured into the tube, the mercury column will oscillate for a short period of time before finally coming to rest. So this line drawn in purple color is the original position of the liquid levels. So therefore the mercury levels will oscillate about their respective original levels. So at a certain instant of time, consider the liquid level on the left hand side is an x distance above the original position along the length of the tube. Therefore, on the right-hand side, the liquid level will be an x distance below the original position along the length of the tube. So, as this angle is alpha, the perpendicular distance from the original position to the liquid level on the right-hand side will be x sine alpha. And as this angle is beta on the left-hand side, the perpendicular distance from the original position to the liquid level will be x cos beta. So therefore, the total perpendicular distance between the two liquid levels will be x cos beta plus x sine alpha. So if we take the total perpendicular distance between the liquid levels as h, that will be equal to x cos beta plus x sine alpha. So that is equal to x into cos beta plus sine alpha. So that is the total perpendicular difference between the liquid levels. So due to this high difference, an excess pressure will act on the liquid column through this point. So if the excess pressure is P, that is equal to H rho G. So rho is the density of mercury. So x is equal to x into cos beta plus sine alpha and rho g. So therefore, this is the excess pressure that acts on the liquid column. So due to this excess pressure, a force will act on the liquid column. So let's take that force as F. So that will be equal to the excess pressure into the cross-sectional area. So therefore, the force will be equal to x cos beta plus sine alpha rho g into a. So now, according to the Newton's second law, we can apply F equals ma. So they have given the mass of the mercury column as m. So therefore, F will be x rho g a into cos beta plus sine alpha, and that will be equal to the mass into acceleration. So here the acceleration will be in the downward direction, but the displacement is measured in the upward direction. So therefore, the direction of the displacement is opposite to the direction of the acceleration. Therefore, here x will be negative. So you all know that in simple harmonic motion, always the acceleration occurs opposite to the direction of displacement. So now we can subject the acceleration here. Therefore, A will be equal to minus A rho g into sine alpha plus cos beta over m into x. So you know that the acceleration is equal to minus omega squared x in simple harmonic motion. So here this whole term is equal to omega squared. Therefore omega squared is equal to a rho g sine alpha plus cos beta over m. Therefore omega is equal to root a rho g sine alpha plus cos beta over m. So they are asking for the period of the simple harmonic motion. Therefore, the period t is equal to 2 pi over omega. So therefore, t is equal to 2 pi into root m over a rho g sine alpha plus cos beta. So therefore, accordingly, the correct answer is the third one. Question number 42. Choose the graph which correctly represents the variation of the resistivity rho with absolute temperature T for a superconductor. So first of all, let's see how the resistivity varies with temperature in normal conductors. So in normal conductors, the resistivity varies with temperature like this. So that means when the temperature is increased, the resistivity or the resistance of normal conductors are increased. And when the temperature is decreased, their resistivity decreases. Then for semiconductors, the resistivity varies with temperature like this. So that means when the temperature is increased, the resistivity of semiconductors decreases. But in certain conductors, when the temperature falls below a certain specific temperature, their resistance becomes exactly zero, and such conductors are known as superconductors. The temperature at which the resistance becomes zero in this manner is called the critical temperature. So for superconductors, the variation of the resistivity rho with the absolute temperature T is correctly shown in this graph. So here you can see this is the critical temperature. So at the critical temperature, the resistance becomes zero. And when the temperature falls below the critical temperature, it becomes a superconductor. So therefore, the correct answer is the fifth one. Question number 43. The efficiency of the transformer given in the figure below is 100%. The ratio of the number of turns in the secondary coil to the number of turns in the primary coil is 1:20. The primary coil is connected to an AC supply of 240 volts, while a resistor of 6 ohm is connected to the secondary coil. The current through the secondary coil is. So here uh, we can easily do this question. So we can write that the number of turns in the secondary coil divided by the number of turns in the primary coil is equal to the voltage in the secondary coil divided by the voltage of the primary coil. So they have given that the ratio of the number of turns in the secondary coil to the number of turns in the primary coil is 1:20. So this should be 1/20. So that is equal to the voltage in the secondary divided by the voltage in the primary coil is 240 volts. So therefore, the voltage in the secondary coil will be 12 volts. Then we can apply V equals IR to the secondary coil. So the voltage is 12 volts and we should find the current and the resistance is 6 ohm. So therefore, the current will be 2 amperes. So then the current that flows through the secondary coil is 2 amperes. So the correct answer is the third one. Question number 44. A closed-loop configuration operating on the feedback conditions is a primary usage method of op-amp. As shown in the figure, two op-amps are connected together while Vin is equal to 4 volts. Output voltage Vout at that instance would be. So here, these are the two op-amps and the positive input is grounded in both the op-amps. And they have given that the input voltage is 4 volts and we should find the output voltage. And here, both the op-amps are in the closed loop configuration. So there are two golden rules that can be applied to the op-amps in the closed loop configuration. So the first golden rule states that when an op-amp operates in the linear region, the voltage difference between the two op-amp input terminals is equal to 0. And the second golden rule states that the current flowing into the op-amp input terminals is equal to 0. So here, as the positive input is grounded, the voltage at the positive input is 0 volts. And according to the first golden rule, as there is no voltage difference between the two op-amp input terminals, the voltage at the negative input is also 0 volts. Similarly here, the voltage at the positive input is 0 and the voltage at the negative input is also 0 volts. So now you can see the input voltage is 4 volts and the voltage here is 0 volts. And as a current always flows from a higher voltage to a lower voltage, here the current flows in this direction through the 2 kilo ohm resistor. And according to the second golden rule, as no current flows into the op-amp input terminals, here the same current flows through the 2 kilo ohm resistor and the 4 kilo ohm resistor. And you know V is equal to IR and therefore I is equal to V over R. So let's take these two currents as I1 and I2. Therefore I1 is equal to I2. So therefore, V1 over R1 is equal to V2 over R2. That means the voltage difference between the 2 kilo ohm resistor divided by its resistance is equal to the voltage between the 4 kilo ohm resistor divided by its resistance. So here, the voltage difference between the 2 kilo ohm resistor is 4 volts minus 0 volts. So that is 4 volts divided by 2 into 10 to the power 3 ohms. That is equal to the voltage difference between the 4 kilo ohm resistor, that is V2, divided by 4 into 10 to the power 3 ohms. So here 10 to the power 10 to the power 3 cancels, and V2 is equal to 8 volts. So as the current always flows from a higher potential to a lower potential, the voltage at this point will be minus 8 volts. So as the voltage difference between the 4 kilo ohm resistor is 8 volts. And now here you can see the voltage here is 0 volts and the voltage here is minus 8 volts. So as the current flows from a higher potential to a lower potential, here the current flows in this direction. And as no current flows into the op-amp input terminals according to the second golden rule, here the same current flows through the 6 kilo ohm resistor and the 8 kilo ohm resistor. Let's take those two currents as I3 and I4. So therefore, as I3 is equal to I4, we can write V3 over R3 is equal to V4 over R4. So V3 is equal to 0 minus 8 volts. So that is 8 volts divided by 8 into 10 to the power 3, and that is equal to V4. We should find the value of V4, and R4 is 6 into 10 to the power 3. So 10 to the power 3, 10 to the power 3 cancels, and 8 cancels. Therefore, V4 is equal to 6 volts. So here also, as the current flows from a higher potential to a lower potential, the voltage at this point will be 6 volts. So therefore, the output voltage is 6 volts. So the correct answer is the second one. Question number 45. The incorrect statement regarding laser light and visible light is: First one, coherent and incoherent. That is correct because laser light is coherent while visible light is incoherent. So what are coherent waves? So coherent waves are those having the same frequency, same wavelength, and a constant phase difference. So as laser lights are monochromatic, that means as they are composed of photons nearly having the same frequency, they are coherent. But as visible light is composed of a mixture of light having different wavelengths or frequencies, they are incoherent. Second one, high intensity and less intensity. Yes, that is also correct. As laser lights are coherent, they can undergo constructive interference, increasing their intensity. Therefore, laser lights have a higher intensity. But as visible lights are incoherent, they have a less intensity. Third one has a phase difference and no phase difference. That is wrong because laser light and visible light, which are both electromagnetic waves, both have a phase difference. Fourth one, created by stimulated emission and created by spontaneous emission. That is correct. Laser lights are created by stimulated emission, while visible lights are created by spontaneous emission. So what is stimulated emission? Stimulated emission is the process by which an excited electron, when exposed to a photon of the same energy as the energy gap between the excited state and a lower energy state, is triggered to drop to a lower energy level and release an additional photon. This newly emitted photon has the same frequency, phase, direction as the incoming photon, which amplifies the light. Then what is spontaneous emission? Spontaneous emission is the process by which an excited electron in an atom or molecule randomly returns to a lower energy state without any external influence, releasing a photon, a particle of light in the process. Therefore, fourth one is correct. Fifth one, smaller bandwidth and larger bandwidth. So what is called bandwidth? Bandwidth refers to the range of wavelengths or frequencies that a light source emits. So in the case of laser light, the bandwidth is very narrow, meaning that the light consists of photons with nearly the same wavelength or frequency. Therefore, laser lights have a smaller bandwidth. Then when we consider visible light as it is composed of a mixture of light having different frequencies or wavelengths, they have a larger bandwidth. Therefore, fifth one is also correct. So as they are asking for the incorrect statement, the correct answer is the third one. Question number 46. The length of a potentiometer wire is 1 meter and its resistance is 10 ohm. The EMF and internal resistance of this driver cell are 2 volts and 1 ohm respectively. A resistance box is connected in series with the circuit. The resistance box is adjusted to have a resistance of R so that the potential difference between the two ends of the potentiometer wire is 1 millivolts. The value of R would be, so this is the potentiometer wire and its resistance is 10 ohm. And this is the driver cell, so its EMF is 2 volts and its internal resistance is 1 ohm. And this is the resistance box, which is adjusted to have a resistance of R. So they have mentioned that the voltage difference between the two ends of the potentiometer wire is 1 millivolt. So here we can easily find the value of R using the potential divider method. So for that, let's take the EMF as E and the resistance of the potentiometer wire as R naught and the potential difference between the two ends of the potentiometer wire as V. Then when we divide the resistance of the potentiometer via R naught by the total resistance of the circuit RT and multiply it by the EMF of the cell E, it will give us the potential difference V between the two ends of the potentiometer wire. So here R naught is equal to 10 ohm and RT means the total resistance, that is 10 plus the internal resistance, that is 1 ohm, plus the value of the resistance in the resistance box is R. So when we multiply that by the EMF of the cell, that is 2 volts, that is equal to 1 millivolts. That means 1 into 10 to the power minus 3 volts. So here when we simplify this side, it's 2 into 10 to the power 4, that is equal to 11 plus R. So R is equal to 20,000 minus 11, that will be 19,989 ohms. So therefore, the correct answer is the third one. Question number 47. Three conducting arrangements carrying the same current I are shown in figures A, B, and C respectively. The magnitudes of the magnetic flux densities produced by these currents at points X, Y, and Z are B1, B2, and B3 respectively. The correct answer when these magnetic flux densities are arranged in ascending order is, so the magnetic flux density at X is B1 and the magnetic flux density at Y is B2 and that in Z is B3. So we can write an expression for B1 and that is equal to mu naught I over 2 pi R. So that is the magnetic flux density at a perpendicular distance R away from a long length conductor carrying a current I. So here mu naught is the magnetic permeability of the medium. Similarly, we can write an expression for B2 and that is equal to mu naught I over 2R. That is because this is a circular conducting coil. And in C, because of the conductor which carries a current I towards the right hand direction, a magnetic flux density is created out of the screen. So you can use the right hand grip rule for that. So here that is created out of the screen. And due to the conductor that carries a current I towards the left hand side, a magnetic flux density is created into the screen. So therefore this is created into the screen. So now for this, for the calculation, I'll take this distance as R. So therefore, we can write an expression for B3 and that is equal to mu naught I over 2 pi R minus mu naught I over 2R. So now we can compare B1, B2, and B3. So first let's compare B1 and B2. So here in B1, you can see a pi term, but in B2, that is absent. So in B1, the denominator is greater than that in B2. Therefore, B1 is less than B2. Now we can compare B1 and B3. So here you can obviously see that because of this term in B3, B3 should be less than B1. So therefore, when we arrange these magnetic flux densities in the ascending order, the correct answer is the fourth one. Question number 48. An ideal gas sample with an initial internal energy U1 is allowed to expand adiabatically. The work done during this process is W. Then, while keeping this volume constant, an amount of heat energy Q is supplied to the gas sample so that the pressure returns to its initial value. If the new internal energy of the gas sample is U2, the change in internal energy U2 minus U1 would be. So this is the first instance, this is the second instance, and this is the third instance. So here there are two processes. So this is the first process and this is the second process. So the initial internal energy is U1 and the final internal energy is U2. So now let's consider the first process. So in the first process, they have mentioned that the ideal gas sample is allowed to expand adiabatically. So in an adiabatic process, there is no heat exchange with the surroundings. So therefore, delta Q is 0 in an adiabatic process. So now let's apply delta Q is equal to delta U plus delta W for the first process. So delta Q is equal to 0. Therefore, 0 is equal to delta U plus, and they have given the work done during the process is W. So therefore, delta U is equal to minus W. And during the second process, what they have done is, while keeping this volume constant, an amount of heat energy Q is supplied to the gas sample. That means the volume doesn't change in the second process. That means it's a constant volume process or an isochoric process. And as delta W is equal to P delta V, as there is no change in volume here, delta V is equal to 0, therefore delta W is also 0. So now we can apply delta Q is equal to delta U plus delta W for the second process. So they have mentioned that the amount of heat energy supplied is Q, therefore Q is equal to, so here I'll take the internal energy change as delta U dash, and delta W is 0. Therefore delta U dash is equal to Q. So they are asking for the internal energy change U2 minus U1. So U2 minus U1 is equal to delta U plus delta U dash. So that is equal to minus W plus Q. So therefore, U2 minus U1 is equal to Q minus W. So therefore, the correct answer is the fourth one. Question number 49. The half-lives of two radioactive elements X and Y are 20 minutes and 40 minutes respectively. Initially, the number of nuclei in X and Y were equal. The ratio of the remaining number of nuclei in X to the remaining number of nuclei in Y after 80 minutes would be. So, as the half-life of X is 20 minutes, for 80 minutes it has 4 half-lives. And when we consider Y as its half-life is 40 minutes, for 80 minutes it has 2 half-lives. So now let's consider the initial number of nuclei in X and Y as A. So now let's consider X. So after 20 minutes, number of nuclei in X will be halved. Therefore, it will be A over 2. And after another 20 minutes, it will be A over 4. And after another 20 minutes, it will be A over 8. And finally, it will be A over 60. So therefore, after 80 minutes, the remaining number of nuclei of X will be A over 16. Now let's consider Y. So after 40 minutes, the number of nuclei will be half. So therefore it will be A over 2. And after another 40 minutes, it will be A over 4. So therefore after 80 minutes, the number of remaining nuclei in Y will be A over 4. So they are asking for the remaining number of nuclei in X to the remaining number of nuclei in Y. So therefore X to Y ratio will be A over 16 to A over 4. So that will be 1 is to 4. So therefore, the correct answer is the second one. Let's move to the last question. Question number 50. A cylinder of radius r is stuck between two rough strips as shown in the diagram. The top strip is moving to the right with a velocity of 5v, while the bottom strip is moving to the right with a velocity of v. If the cylinder is rolling without slipping, what is the magnitude of its angular velocity? So this is the top strip and this is the bottom strip. So the top strip is moving to the right with a velocity of 5v and the bottom strip is moving to the right with a velocity of v. So relative to the bottom strip, the velocity of the top strip will be 4v. So that means if we consider that the bottom strip is at rest, the velocity of the top strip will be 4v towards the right. So therefore, the tangential velocity of this point, that means the highest point of the cylinder, will also be 4v. So therefore, the velocity of the center of mass of the cylinder will be 2v. That is because the velocity of the center of mass of the cylinder is half the value of the velocity at the highest point. So then the velocity of at this point is 0, and then when we consider the rotational speed at the surface of the cylinder will be 2v. That is equal to the velocity of the center of mass of the cylinder. So now we can find omega. So omega is equal to the rotational speed at the surface divided by the radius. So that will be 2v over r. So therefore, the correct answer is the first one. So thank you all for joining this discussion. I hope that you understood it really well. So if you have any questions, feel free to drop a comment below. Study hard and try to understand the really beautiful concepts in physics. And finally, I wish you all the very best with your A-level exam in the near future.